Good evening, everyone, and welcome to today's wonderful evening with Dr. Murli Bharadwaj. I am so addicted to you all guys. Without talking to you, without spending time with you, without being a part of your NEETPG preparation, I don't even get sleep. However, be the hectic day, still you are my world. And thank you very much for joining the session. Very nice to see AJ Kumar. Good evening, sir. I am preparing for MRCP and want to learn the basics. 2K8 batch. Very good. Thank you so much, AJ, for coming. Every day we have around 2 to 3 hours of live broadcast. Please do come. Nice to see Girija and Sai Krishna Reddy. So today morning only I returned from Chennai to Hyderabad. So from tomorrow we will continue live classes face to face. All right. So please do come. Tomorrow we will try to have a class 1 p.m. to 5 p.m. All right. Good to see Varsha and many more who are all online. So doctor, at least half an hour or 45 minutes, let us spend studying together without a break. Right. That is the whole idea. And almost all 18 students who are all online, thanks for joining in the late hour. And we, the NEETPG toppers, determined to be the winners, no looking back. Master 54,000 points, 1,500 pages, and tomorrow 200 questions in NEETPG. We should conquer all the 200 out of 200. That is the goal. All right. So with that, Dr. Preamble, let's start. So we discussed around 43 points in biochemistry. We are continuing that. Can the online students can punch whether the voice is loud and clear for all of you? Is the voice loud and clear? So, universal electron acceptors. So, nicotinamide NAD plus, NADP plus, and FAD that comes from the vitamin B2, the flavin nucleotides. Then why God created one NAD and another NADP? NAD is used as a provider of the reducing equivalents in catabolic processes, glycolysis, etc. Whenever NADH is produced, it is the NADH, not NADPH. Whereas anabolic processes are there, no doctor. Steroid synthesis, fatty acid synthesis, there NADPH is used to provide is generated, is what you need to remember. So from where is NADPH produced? It is the product of hexose monophosphate shunt. Similarly, whenever a macrophage catches an organism and kills it, there is a respiratory burst. There also it is NADPH. Cytochrome P450 system, NADPH. Glutathione reductase, NADPH. That's what you need to emphatically remember. Good to see Seshikala. Girija, can you please punch? Is it the same point at which we ended, or I feel that we finished all these points? What is the point at which we ended in the last discussion? Can you please punch? Now, doctor, HMP shunt pathway. Typically, it is also called pentose phosphate pathway. All right. So, glucose 6-phosphate becomes 6-phosphogluconate. 6-phosphogluconolactone becomes 6-phosphogluconate. From that comes the ribulose 5-phosphate. In every step, NADPH is produced. When the glucose 6-phosphate becomes 6-phosphogluconolactone, NADPH is produced. Phosphogluconate to ribulose 5-phosphate, once more NADPH is formed. This is what you need to remember. So 2 NADPHs are formed. Then once more, this ribulose phosphate, which is a 5-carbon one, right? 5-carbon. It becomes divided into xylulose and ribose. Ribulose to xylulose is epimerase. Ribulose to ribose is isomerase. Once more, this 5 plus 5, 10. They combine to form 1, 7 and 1, 3. This reaction is called transketolase. And for this transketolase, you require the vitamin B1. Thiamine pyrophosphate is what you need to remember. All right. So anyway, 44th point we finished, right? Okay. Still, G6PD, pentose phosphate pathway is worth doing revision every time. So once more, 7 plus 3, how much? 10. So from that, a 4-carbon erythrose and 6-carbon fructose 6-phosphate will form. For that, once more, it is a transaldolase, is what you have to remember. So ultimately, what is the purpose of HMP shunt, doctor? The whole purpose is to generate NADPH and to generate ribose. Ribose is the precursor for the synthesis of nucleic acids, is what you need to remember. So let us go to the point number 45. All this we finished already the discussion, right? Now from here, let us start. This is one of the favorite MCQs in exam, doctor. How many ATPs are produced in glycolysis? How many ATPs are produced in citric acid cycle? Sure, short MCQ. And you should be very good in all these energy calculations. Not that in exam hall you sit and start thinking. There is no thinking in exam hall. Only hitting the right answer. That is the only thing in exam hall. All right. So, doctor, how many ATPs are produced? So, glucose. So, what is the equation, doctor? Glucose plus 2-phosphate plus 2-ADP plus 2-NAD plus will become 2 pyruvate, 2 ATPs, 2 NADH, 2 H plus is what you have to basically remember. So every time this NADH is metabolized, 2.5 ATPs are produced per NADH. That's what you need to remember. Now, how does the glycolysis proceed? Now we came to the core biochemistry discussion. All of you remember our first time biochemistry teacher holding our hand and teaching. After that, there is no other teacher in the medical college who is so affectionate, passionate, benevolent as much as an physio biochem teacher. All other teachers don't even recognize our face also. So, doctor, glucose become glucose 6-phosphate. What is the enzyme? Either hexokinase or glucokinase. Second, phosphofructokinase. It is a rate limiting step. Please don't forget. Fructose 6-phosphate become fructose 1,6-biphosphate. Now, what regulates this phosphofructokinase? Always the end product of a reaction controls and has a negative feedback effect on the enzyme. You know that very well. So whenever we have too much glucose 6-phosphate, right? Too much glucose 6-phosphate, it has a negative effect on hexokinase. Because hexokinase converts glucose to glucose 6-phosphate. Glucose 6-phosphate is the end product. That's the reason glucose 6-phosphate has got a negative effect on hexokinase. Similarly, fructose 6-phosphate has a negative effect on glucokinase. So there are two things, hexokinase, glucokinase, both of them do the same reaction. Glucose to glucose 6-phosphate, but it is the glucose 6-phosphate which has a negative effect on hexokinase, but fructose 6-phosphate has a negative effect on glucokinase. This is the fine point you need to catch. Examiner will ask small questions only, right? He will give glucokinase is inhibited allosterically by which inhibitor? Is it glucose 6-phosphate or fructose 6-phosphate? Then you will be thinking, okay, boss, glucokinase converts glucose to glucose 6-phosphate. That's the reason glucose 6-phosphate should be the inhibitor. No. Glucose 6-phosphate is the inhibitor of hexokinase, but fructose 6-phosphate is the inhibitor of glucokinase. The thing done by hexokinase and glucokinase is same, but the inhibitors are different. Then phosphofructokinase is what happens. If there is AMP means you don't have money, you are a beggar, you want money. How will that come? Glycolysis should run. Glucose should be broken down. That's the reason high AMP means you have a lot of debts. You are a beggar. That stimulates the phosphofructokinase to run the glycolysis forward. That's the reason AMP has a stimulating effect on phosphofructokinase. Then fructose 2,6-biphosphate, not 1,6, 2,6-biphosphate. That also has a stimulant effect on phosphofructokinase. ATP means you already have a lot of money. You don't know what to do with all the black money. So it has an inhibiting effect on phosphofructokinase. Similarly, citrate. Ultimately, all the glucose, end of the glycolysis become pyruvate. Pyruvate typically enter into the citric acid cycle and form citrate. Already, if a lot of citrate is there, you don't need pyruvate. Because citrate forms from pyruvate, right? A lot of citrate is there means you don't need pyruvate. Already, if your citrate is high, you don't need pyruvate. So when you don't need pyruvate, glucose need not convert into pyruvate. That means glycolysis need to be inhibited. That is the reason citrate, when it is excessive, will come back and tell the rate-limiting enzyme, which is the phosphofructokinase, to shut down. That's what you need to remember. So totally 3 enzymes. And what are their inhibitors? Glucose 6-phosphate, hexokinase, glucokinase, and phosphofructokinase. These 3 enzymes and what are their inhibitors is the favorite question of the examiner. So very good to see Dr. Amulya, Dr. Shashikala, many more friends. If you are from Hyderabad, please come to our live class. We will all enjoy a study together, right? Now, in which steps of glycolysis ATP is produced? When phosphoglycerate kinase is converting 1,3 is forming 1,3-diphosphoglycerate to 3-phosphoglycerate conversion it is doing. That is the step at which ATP is produced. Then when pyruvate kinase is converting phosphoenol pyruvate to pyruvate, that is the second step where energy ATP is produced. And how is the pyruvate kinase is regulated? Once more, same story. If a lot of ATP is there, you don't need pyruvate kinase to produce ATP, na? So ATP has a negative effect on pyruvate kinase. If a lot of alanine is there, or glucagon, they all have a negative effect on pyruvate kinase. Fructose 1,6-biphosphate, which is the precursor, it has a stimulant effect on pyruvate kinase. So you need to remember, doctor, what is below, what is above. So if you look at the glycolysis, right? You have phosphoglycerate kinase. All right, doc? Phosphoglycerate kinase. And you are having fructose 6-phosphate. Fructose 6-phosphate ultimately comes down to produce biphosphoglycerate, which become converted into 3-phosphoglycerate, and during this step ATP is produced, right? So this is the precursor of, it is not end product, it is a precursor. Always a precursor stimulates. Precursor stimulates is what you need to remember. Just like precursor is like daddy. So daddy stimulates to become something great. But end product is like a hubby. Hubby discourages. I mean, vice versa can happen, just for you to remember, right? That is what you need to emphatically remember for the tomorrow's exam. So, doctor, this is the phosphoenol pyruvate become pyruvate. And fructose 1,6-biphosphate stimulates ATP and alanine inhibit. So how does it happen? This pyruvate kinase enzyme is there, no doctor, which is converting phosphoenol pyruvate into pyruvate. In the dephosphorylated form, it is more active. Whereas phosphorylated form, it is less active. This is what you need to emphatically remember. So glucose become glucose 6-phosphate. Hexokinase is converting, and that is inhibited by glucose 6-phosphate. You're not going to forget. Fructose 6-phosphate become fructose 1,6-biphosphate, and that is the fructokinase, phosphofructokinase 1, that is stimulated by fructose 2,6-biphosphate, AMP, and inhibited by ATP, citrate, and H+. So these are all sure short questions, doctor. If you say I'm going to NEETPG, I'm going to USMLE, but I don't know this means, nobody will excuse you. Phosphoenol pyruvate become pyruvate, and what is that enzyme? Pyruvate kinase. So fructose 1,6-biphosphate stimulates it, ATP and alanine inhibit it. These are the things you need to remember forever and ever, not ever and ever, at least next 6 months. Okay. So now, doctor, is the voice is loud and clear, doctor, for all the online students? Please reassure me. If it is a live class, face-to-face class, I never have that problem. There will be one manager who will be monitoring, but since I am delivering from the home, please kindly check that and let me know, doctor. Is the voice loud and clear? Please punch. Now, how does fructose 2,6-biphosphate regulates the glycolysis? Let's look into this story. So there are two enzymes, doctor. One is called fructose bisphosphatase 2 and phosphofructokinase 2. They both are the same bifunctional enzyme, right? And in turn, they will be either in a phosphorylated form or a dephosphorylated form. It depends on whether protein kinase A is causing phosphorylation or not. Now, if you are fasting, doctor, you are fasting. Let us say you are fasting. You don't have glucose. Then that stimulates the glucagon to get produced. Glucagon secondary messenger is cyclic AMP, which will increase. And that will cause increased protein kinase A. And that increases the fructose bisphosphatase 2. And it also increases phosphofructokinase 2. And that lead to less glycolysis and more gluconeogenesis. It's a switch phenomenon. Suppose you are fed, you ate chicken biryani, mutton biryani, all biryani, then you have a lot of glucose already in your blood. That stimulates insulin. Insulin decreases cyclic AMP. That decreases the protein kinase A. That decreases the phosphorylation of the fructose bisphosphatase. And that is one thing. And phosphofructase kinase 2 is increased. There is a more glycolysis and less gluconeogenesis. So it is all whether protein kinase is phosphorylating or not phosphorylating. And it depends only on two enzymes, which is fructose bisphosphatase 2 and phosphofructokinase 2 is what you need to remember. So let us look into it, doctor. Anything that causes decreased fructose 2,6-bisphosphatase inhibits glycolysis, stimulates gluconeogenesis. Anything that causes an increased fructose 2,6-bisphosphatase stimulates glycolysis, inhibits gluconeogenesis. So fructose bisphosphatase 2 is inactive when it is phosphorylated, which is done by typically it is inactive typically whenever there is a dephosphorylation. So phosphoprotein phosphatase, insulin stimulates that, and typically that loses a phosphate, and in turn that will convert the fructose bisphosphatase 2 from an inactive into an active form, and that increases the activity of the fructose 2,6 bisphosphatase. So this is how the cycle goes on. So please remember this important regulatory slide, doctor. Fundamentally, you need to know PFK2, FBPase2. These are the two things which are important. High F26BP, that is fructose 2,6 bisphosphatase, stimulates glycolysis, inhibits gluconeogenesis. Decreased fructose 2,6 bisphosphate inhibits glycolysis, stimulates the gluconeogenesis. Agreed, doctor? So this is very, very important to remember. So whenever insulin is acting, so what is the function of insulin, doctor? Insulin, whenever it is increased, it decreases cyclic AMP, decreases protein kinase A, decreases fructose bisphosphatase activity, and that lead to more glycolysis and less gluconeogenesis is what you need to remember. Now, doctor, Pyruvate Dehydrogenase complex, PDH. What do you remember about it? So all these points, doctor, they're all available in the form of 1500 pages notes. Today the problem is big books, too much study material, for every subject one book, too much material. Or the other thing, what happens, a lot of coaching centers, only 60% of what they teach in the videos, because to increase the video sales, 60% only they provide as a notes. Both the things are dangerous. Remember, I like to tell you, I will give you 1500 pages notes with 54,000 points, not a single point missing, and 600 hours video, around 10,000 short videos, into which all these 54,000 points are revisable. But the point is what, doctor? Video makes your preparation and revision very slow. Listen video only if you are not sure about that particular point in the notes given to you. Otherwise, don't read. Don't listen video. It's a waste of time. Complete bullshit video. So what you need is perfect notes from which 200 questions come. I promise that I will give you that perfect 1500 pages notes. अगर 200 out of 200 points उसमें से नहीं आए तो मेरा जिम्मेदारी. Then what is the technique that you need to follow, doctor? It takes 600 hours for the first revision to finish the 54,000 points in the 1500 pages. Second revision should take only 200 hours. Because you are not listening videos, no? Idiotic, dumb bullshit called videos, you are not listening to them. You are quickly doing the revision, and those points which you are bookmarked in the first reading, you are doing revision. Maximum another 100 hours you will take for the second revision. Bus. If you don't get seat, Mera naam Murli Bharadwaj nahi. You got the strategy, right? 1500 pages, 54,000 points. I deliver live session of 600 hours and archive that video into the Score app. Agreed? So you need to invest 600 hours for the first reading, because only if you read notes you won't remember. A lot of points require some amount of discussion. For that purpose, if you attend live class, you don't need to go to video. Otherwise, directly, if you have not attended our earlier 200 hours completed, what you do is go through the notes, tick it, okay, this point I need video clarity. Go to the video in the Score app and just listen that video. Done. 600 hours, be ready to invest and at least one round master the 1500 pages. Then second round, only bookmarked points, quickly sit with a friend and do the revision. 200 hours may you can finish all the 1500 pages. Wait for notification. Notification came. Next 100 hours, finish the third round. Go to the exam. All 200 questions will be point to point in this 1500 pages notes which I'll be giving you. Simple way to succeed the NEET PG exam to become topper. You don't need to run behind so many things which are, I don't say they're bad, they're good. But the problem is they're so vast, not needed. You are preparing not to become a Gyani. You are only preparing to become a NEET PG. Kaun banega NEET PG pati. Kaun banega NEET PG pati. That's for what you are coming to a coaching center, right? So if you are from Hyderabad, be my guest. Every day, 3 hours, masala chai, Charminar biscuits, everything will be available. And on Sundays, don't forget, there is a grand test of 200 questions just with clinical vignettes, image-based questions, everything made available on the score app. Solve that paper, attend the live discussion. Every Sunday you do that. Last December month, every alternate day we will have a full-scale grand test and discussion. By the time you should finish all these 1500 pages revision. All right, doctor? Very good. Nice to know, Shrestha Chinu. Sir, I received 1 volume of notes. Very good. Every month we will send you 1 volume, doctor. I don't want to load you. And even I also prepare everyday notes and then it get ready, right? So I'm also becoming a NEET PG student like you. So every month we will send you 500 pages notes. In next 3 months, you will get all the 1500 pages notes. All right, doctor? So that is the whole goal of our preparation. See, one simple thing, doctor, remember, if you look at this one paragraph, how many things are there to remember? Where will you remember if you have extensive study material? Suppose if I say regulation of glycolysis, fructose bisphosphatase 2, phosphofructokinase 2, the bifunctional enzyme, which is reversed by phosphorylation. Then you need to remember what happens in fasting. High glucagon, high cyclic AMP, increased protein kinase, increased fructose bisphosphatase 2 activity, increased phosphofructokinase 2, and less glycolysis, more gluconeogenesis. That's how you need to ultimately end up in remembering. In one paragraph only, there is so much to mug, so much to remember, so much to reproduce. Small things, increase become decrease, decrease become increase. Totally different marks will come in the tomorrow's exam. That's the reason, don't get informationally loaded, doctor. Enjoy preparation to entrance. Is a cool job with Dr. Murli Bharadwaj. Be in the WhatsApp study group. I'm posting lot of questions every day. Keep guessing the answer. If you don't get the answer, just go to internet or whatever it is and then post. Get involved. By that, what happens is that habit of preparation need to go on in a group, doctor. That's very important. Pyruvate dehydrogenase complex. It is a mitochondrial enzyme complex and it links glycolysis and citric acid cycle. The pyruvate dehydrogenase complex typically connects glycolysis. End product of glycolysis is pyruvate and that is converted into acetyl-CoA. And to convert pyruvate to acetyl-CoA, oxidative decarboxylation should occur. That is the one which is powered by pyruvate dehydrogenase complex. It is very active when you are in a fed state and it is inactive whenever you are in a fasting state. All right. So what is the reaction? Does it regulate, doctor? Pyruvate plus NAD plus CoA will give you acetyl-CoA decarboxylation. CO2 is released. Oxidative, that means NADH is formed. And basically it contains 3 enzymes that require 5 cofactors. Thiamine pyrophosphate, lipoic acid, and coenzyme A. You remember, no? PAN is pantothenic acid. PAN hota hai, panch hota hai B5. B5 is pantothenic acid, which is the part of coenzyme A, is what you need to remember. Then it requires riboflavin, which is FAD. Then it requires vitamin B3, which is NAD. And what activates pyruvate dehydrogenase, doctor? Whenever NAD plus by NADH ratio has increased. That means there is more NAD plus, less NADH, then you need to produce NADH. And since this pyruvate dehydrogenase produces NADH, high NAD plus by NADH ratio stimulates pyruvate dehydrogenase complex. Similarly, NADH ultimately will cause ATP production. That's the reason if there are more ADPs, then you need more ATPs. So how do you produce ATPs? Only if you run the pyruvate dehydrogenase complex and produce NADH, and that become ATP, right? That's the reason high NAD plus by NADH ratio, high ADP, high calcium will lead to pyruvate dehydrogenase complex to be stimulated, is what you need to remember. So don't forget one important point: pyruvate dehydrogenase complex is not cytosolic, it is mitochondrial. Whereas the pyruvate is produced in glycolysis, which is cytosolic. And the pyruvate dehydrogenase converts pyruvate into acetyl-CoA. But acetyl-CoA once more is used by the citric acid cycle, which is there inside the mitochondria. So that compartmentation, which biochemical reactions occur in mitochondria, which occur in cytoplasm, oh my God, that is the most important MCQ which you should not forget, doctor. So remember that pyruvate to become acetyl-CoA, you have the pyruvate dehydrogenase complex that forms NADH. Calcium stimulates this reaction. That's what you need to remember. Whereas any insulin resistance or free fatty acids, they typically will inhibit the pyruvate dehydrogenase complex, is what you need to remember. So, if you look at pyruvate dehydrogenase complex, doctor, it is very similar to one of the enzymes in citric acid cycle, which is called alpha ketoglutarate dehydrogenase complex. Both of them require same cofactors like thiamine, both of them require folate, both of them require similar kind of cofactors. But what does alpha ketoglutarate dehydrogenase does? It converts alpha ketoglutarate into succinyl-CoA, where in citric acid cycle. And alpha ketoglutarate dehydrogenase also requires the same cofactors like pyruvate dehydrogenase. That is, it requires vitamin B1, thiamine, vitamin B2, vitamin B3, B2 which is the folate, B3 which is the nicotinamide, B5 which is pantothenic acid, and lipoic acid. Same things it also requires. So this important graphic you need to have in your heart, doctor. Pyruvate dehydrogenase is inactive when it is phosphorylated, and it is active when it is dephosphorylated. So dephosphorylation is done by pyruvate dehydrogenase phosphatase. So calcium basically activates this and makes pyruvate dehydrogenase become active. Whereas when NADH is high, or if ATP is high, or if acetyl-CoA is high, all that will stop the PDH and make it inactive, is what you have to emphatically remember for the tomorrow's exam. Now comes arsenic acid. So, doctor, entire biochemistry, do you know in how many pages I do the complete revision of the biochemistry? You will surprise. Just 50 pages. बस आप एक मोटा 300 pages book, all is waste, not required. 50 pages, each page which run into 10 paragraphs, 30 points in 50 paragraphs. But remember, doctor, I will take around 25 hours to do the revision of these 50 pages. If you are attending live class, great. Otherwise, if you are attending video library, you have 50 hours, 25 hours of video made available. Like 10-minute video, 10 minutes is one video. So 1 hour is 6 videos, 25 hours is, you have around 150 videos. So 150 videos are there. Small videos, 10-minute videos. You won't get bored. But when the notes is there before doctor, you don't need video also. If you are not able to understand this, then go to the video because you have all that PowerPoint slide and all that available. If you can remember it easily with your friend, you don't need the video. Okay? So that's how you need to optimize your time, doctor. Time is the only constraint. The time, correct time management is all about the NEETPG, doctor. Now, arsenic acid and the pyruvate dehydrogenase complex. What is the relation between the two? Is the broadcast clear for everybody, doctor? Is it coming in a blocks or stopping? Please let me know whenever you have any disturbance. Is it clear for all of you? Without a breaks, it is coming, right? Because I'm using the internet in the home. Arsenic inhibits the lipoic acid, which is the component of pyruvate dehydrogenase complex. So whenever arsenic poisoning is there, there's a pigmentary skin change, skin cancer can occur, vomiting and diarrhea, QT interval become prolonged, garlic breathing will be there. All this, once more, we are going to read it in forensic medicine. So please don't forget. So whenever arsenic toxicity is there, pyruvate dehydrogenase complex is inactivated. So when it is inactivated, there's a decreased acetyl-CoA production, decreased citric acid cycle, then decreased gluconeogenesis, decreased fatty acid oxidation. That all will kill the person. Now, in few people, whenever they are not taking adequate thiamine or congenital inborn error, pyruvate dehydrogenase complex deficiency can occur. So whenever the deficiency is there, what will happen? That builds the pyruvate, that becomes lactate because pyruvate dehydrogenase is not available to convert the pyruvate into acetyl-CoA, right? So pyruvate has 3 fates. There are 3 fates for pyruvate. 1, it can become lactate. It can become alanine, or it can become acetyl-CoA by the action of pyruvate dehydrogenase. So if the pyruvate dehydrogenase is not there, then it becomes more of alanine, more of lactate. Typically, that lead to lactic acidosis, increased serum alanine, neurological defects. So how do you treat it? Typically, you have to increase the intake of ketogenic nutrients, that is high fat content, or increased lysine and leucine. Increased lysine and leucine. That's called ketogenic nutrients. You need to give more. Whenever pyruvate dehydrogenase complex deficiency is there, is what you need to remember. So if you look at the metabolism of the pyruvate, there are so many pathways pyruvate will take. We have seen, right? 1, alanine aminotransferase converts pyruvate to alanine. Agreed? Pyruvate to alanine aminotransferase. It requires vitamin B6. Please don't forget, doctor. They're all small things. But examiner tomorrow will catch your neck only in these areas. Already we discussed in the vitamins, right? Vitamin B6 is the part of many aminotransferases. Vitamin B6, pyridoxine. Then alanine carries the amino group to the liver from the muscle. So typically in the muscle, whenever too much pyruvate is being produced by the glycolysis. That pyruvate is converted into alanine, and alanine will take the amino group to the liver, and there it is metabolized. Then pyruvate carboxylase. So typically oxaloacetate converts, can replenish the citric acid cycle, or it can be used in gluconeogenesis. For that, you require pyruvate carboxylase. Pyruvate carboxylase converts pyruvate into oxaloacetate, and that oxaloacetate is used in the citric acid cycle. Or oxaloacetate can become the phosphoenol pyruvate and go back to form glucose, gluconeogenesis, reverse direction. So oxaloacetate formed from the pyruvate by the action of the pyruvate carboxylase is used in the citric acid cycle, or oxaloacetate is converted into phosphoenol pyruvate by the phosphoenol pyruvate carboxykinase. And that in turn will take it in a backward direction to form the glucose. That's the reason the pyruvate's end product, oxaloacetate, can help the gluconeogenesis. So glucose breaks down to form pyruvate. Pyruvate become oxaloacetate. Oxaloacetate form phosphoenol pyruvate. Phosphoenol pyruvate once more goes back and forms glucose. That is how the whole story is regulated. Pyruvate dehydrogenase, which has vitamin B1, B2, B3, B5, and lipoic acid, typically converts pyruvate into acetyl-CoA, and that's how it enters into citric acid cycle. Then you have a lactate dehydrogenase. Lactate dehydrogenase, when pyruvate become lactate, lactate dehydrogenase is the one which works. And during the process, NAD plus become NADH. And that NADH require nicotinamide. That's the reason vitamin B3 is required for lactic acid dehydrogenase. So whenever there is an anaerobic glycolysis, because if the pyruvate, normally how will glycolysis will end? Glycolysis will end into pyruvate. Pyruvate become acetyl-CoA, right? Acetyl-CoA. My pen is not there. I'm just using the mouse. Apologize me. And acetyl-CoA will be used in the citric acid cycle, which runs in mitochondria, and that produces the NADH. NADH runs through the electron transport chain, which is also there in mitochondria, and produce ATP, and ultimate acceptor of that electron is oxygen in the electron transport chain. Suppose if oxygen is not there, pyruvate cannot go through this karma. Pyruvate cannot become acetyl-CoA, acetyl-CoA cannot go into the mitochondria and electron transport chain and all that. So in that case, whenever oxygen is not there, whenever anaerobic conditions are there, or if there is no mitochondria, like in RBCs, red blood cells, in all these scenarios, what will happen? Pyruvate typically become lactate. That's called anaerobic glycolysis. Similarly, RBCs, WBCs, kidney, medulla, lens, testis, cornea, in all these situations also, it is lactic dehydrogenase that convert pyruvate into lactate and produce NADH is what you need to remember. So you should know what are the various fates of this most important pyruvate produced. So when pyruvate is produced, it can become acetyl-CoA that combines with oxaloacetate to form the citrate and enter into citric acid cycle. Fate number 1. Fate number 2, pyruvate can become by the action of pyruvate carboxylase to become oxaloacetate, which can enter citric acid cycle. Then pyruvate typically can become lactate using LDH and produce and consume the NADH. Yeah, that is another fate whenever anaerobic glycolysis is there. Similarly, pyruvate typically form oxaloacetate. Oxaloacetate can become phosphoenol pyruvate, and that in turn will go and form glucose. That's called gluconeogenesis. So these are all the consequences and fates of the pyruvate is what you need to remember, doctor. So now, citric acid cycle. We'll study citric acid cycle and call it a day, doctor. Citric acid cycle is also called Krebs cycle. All of us know. Now, what are the steps? Let us see. Pyruvate first become acetyl-CoA and produce 1 NADH. Then when citric acid cycle completely runs, it lead to how many? 3 NADH, 1 FADH2, 2 carbon dioxide, 1 substrate level phosphorylation. That is 1 GTP is produced for every acetyl-CoA. So typically 10 ATPs are formed totally, and whenever acetyl-CoA is formed, how many acetyl-CoAs are formed for every glucose molecule? Every glucose become ultimately 2 pyruvates, and each pyruvate will form 1 acetyl-CoA. So 2 pyruvates form 2 acetyl-CoA. So 2 acetyl-CoAs are formed every time glycolysis occurs. So citric acid cycle occurs in mitochondria. So citrate is Krebs starting substrate for making oxaloacetate. All eight. Citrate is Krebs starting substrate for making oxaloacetate. Please meditate and try to remember this, oh my NEETPG mate. Kya shairi hai, right? So this is what we need to remember, doctor. So what I will do is, this requires a very good pen and explain you. So tomorrow's class, I'll be there in the live classroom with everyone. So I'm so happy you all came for the live class. Tomorrow we'll have a long session, 4-5 hours of session, doctor. And we will try to finish half of biochemistry. All right. So thank you very much. Study every day. You have Dr. Murli Bharadwaj, who will hold your hand, study with you, ask you questions in the WhatsApp group. Sometimes in the midnight, it will be ting, 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 the new questions. Whenever I get time, I put questions. Apologize me. But thank you for remaining in the WhatsApp study group without leaving. And please ask all your other friends also to come and join the WhatsApp study group. See you all tomorrow, doctor.